Hey guys, today we're going to look at a tutorial as to how to use ARKit. It's going to be just a basic introduction as to how to use it, what the different features in it are. And keep in mind this does require your device to run it to be on iOS 11. So currently we're in the iOS 11 beta. So if you don't have it, you can download it in the description below. And also you need to use Swift 4, which requires the Xcode 9 beta. That's also in the description below because they aren't released yet, which they will be quite soon. So let's get into ARKit. Okay, so now we're in Xcode. We've created a new single view application. And what we need to do is go to your main.storyboard, and in the Object Explorer in the bottom right, we simply need to drag ARKit view onto our view controller, make that take up the whole screen, and then we're going to add 4 constraints to the top, right, bottom and left, so we will always take up the whole screen no matter what the device. Next up, add 2 buttons. The first one will be in the bottom left. This is going to add a cube to our augmented reality, and we'll add some constraints to the bottom and left, the width and height. Next up, add another button. We're going to call that add cup to add a cup object to our augmented reality. So these are a virtual cup and virtual cube. Make that button a bit bigger once again. Stick it in the bottom right and also select width and height for the constraints. Once we've added the buttons, head over onto the attribute inspector, and we are going to change the background on both of them to green. The reason for this is this AR scene view is going to show the camera, so it's going to show what's on your camera, so it makes it a bit easier to see these buttons for our tutorial demonstration. Now what you want to do next is go over to the info.p list, click on the plus on one of these keys and add in the key privacy-camera usage description. Our value is set to we need your camera to show you cool VR stuff, but this should be AR for augmented reality. And this will allow us to get access to the user's camera, otherwise the app will crash straight away. So now that we've done that, in our main.storyboard, we need to connect up these objects. So first of all, to connect up the scene view, with our assistant editor open in the top right to show our view controller, drag that in here. Now add it as a scene view. As an outlet. And once you add that, it's going to show an error here. And the reason for that is under import UIKit, we need to add import ARKit and also import SceneKit to import the AR and SceneKit libraries. And give it a moment and this error will now disappear because this AR scene view is part of these libraries. Next up, connect up the add cube as an action. We'll call it add cube. Connect that up. And finally, we'll go add cup as an action. Now that we've done that, close down the assistant editor view and go to our view controller. And under view did load, let's set up our first augmented reality by adding a cube. So to do this, we'll do let configuration equals AR world tracking session configuration brackets, do configuration dot plane detection equals dot horizontal, and now scene view dot session dot run, and the configuration is going to be configuration, and we don't need any options. These are optional, funnily enough, so we'll just get rid of that here. So this here sets up a session configuration, and this runs the view session. Just a quick note, this AR world tracking session configuration, as in the documentation here, only runs on iOS devices with an A9 processor or later. Otherwise, if you have a device that supports augmented reality but does not have an A9 processor, you can use this AR session configuration task, which will also let you use augmented reality but will be slightly less immersive, so it'll be a bit slower and probably not as accurate. And also, with this code, this here is a basic augmented reality tracking. You can get more advanced by using a concept called planes, and this allows you to essentially detect a surface such as carpet, tables, and so on. And from this will allow you to place objects on those surfaces accurately. So that's covered more in the Apple documentation. In this tutorial, I'm going to show you how to place basic objects in augmented reality. So now that we've done that, let's add a cube to augmented reality. So to do this, we'll do var cube node equals scn node brackets. We'll do geometry, and in geometry we'll do scn box brackets, do width, height, length, and so on. So width is going to be 0.1, height is going to be 0.1, length is going to be 0.1, and finally the chamfer radius will be 0. So this is going to create a cube which is 10 centimeters in width, 10 centimeters in height, and 10 centimeters in length. Finally, we'll do cube node dot position equals scn vector 3. I'm going to do 0, 0, minus 0.2, and this coordinates are expressed in meters, and this is going to place the cube just slightly in front of our face with 20 centimeters. So this is in meters. Now finally we'll do scene view dot scene dot root node dot add child node, and we need to add the cube node. And we'll change that var for cube node to a constant for now, because we're not changing it at all, to get rid of that warning. Now we've set up our first augmented reality app. Let's run it and take a look at the cubes in our augmented reality world. Alright, we can see our augmented reality up here. Now if we add a cube, we can see our cube up here. But if we tap add cube, it doesn't actually add any more cubes. So why is that? Well, let's take a look at the code and I'll show you how we can add more cubes and why this is happening. Okay, so the reason we can only place one cube is when you start ARKit, the root node, which is the kind of position of your device, is at 0, 0, 0 in 3D coordinates, which is X, Y, and Z. And the cube is placed in relation to this. So by tapping adding cube a bunch of different times, we're actually adding cubes in the exact same spot, because the cube gets placed in relative position to this root node and not the actual camera. So let's randomize the placement a bit just to show you why this happens and to kind of prove it out. So we're going to use a random number generator, which is covered on my website, seemuapps.com. So we're going to grab the random float function, which you can also grab in the description below. And what we are going to do, we're going to do let z coords equals random float. The minimum is going to be -2. The maximum will be -0.2. And finally, we'll change this position from -0.2 to be Z coords. Now let's run that again and see what happens with our cube when we place multiple cubes. Alright, so now we've got the app here with a random number generator for the Z position. So if we add a bunch of cubes, we can see they get placed in relation to the location the app will start it at. If you start the app, move around, tap add cube, they'll get placed in front of the camera where the app started. So we can see our line of cubes here. So that's how that works, why the cube got placed initially in the one spot and why we couldn't add any more. So let's take a look at adding a cube in the position of the camera. Okay, so now let's look at how we can place the cube at the position of our camera so we can place it wherever we want in our world. So to do this, we're going to create a structure called my camera coordinates. And this structure is going to have 3 variables. And just get rid of that bracket here. So var x equals float type, var y equals float, var z equals float. Now we create a function to get the camera coordinates. And this is going to be taking a scene view as an argument of the type ARSCN view. And it's going to output a my camera coordinates. And we'll do let camera transform equals scene view dot session dot current frame question mark dot camera dot transform. If I want to do let camera coordinates equals MDL transform, and this takes in a matrix, and the matrix is going to be camera transform. So this matrix is a special data type to kind of tell you where an object is in 3D space, but we need to convert it to a different type in order for it to work. So now that we have the camera coordinates, we do var cc equals my camera coordinates, do cc.z equals camera coordinates dot translation dot x to get the x z, change it to z to get the z position. And finally, we'll also add in x and y above that. So the first one will be cc.z, cc.y, translation.y, and then we do return cc, which is camera coordinates. So that's how we get the camera coordinates from our scene view. So we pass in our scene view to just get camera coordinates, and it will return this my camera coordinate structure, which contains the coordinates in x, y, and z, so 3D space. So to place a cube at our camera coordinates, let's just comment out this position for now. Actually, I'll delete it, and we'll delete this z coordinates. And to do this, we do let cc for camera coordinates equals get camera coordinates, which is the function we just made, and we pass it in our scene view. And then we do cube node dot position equals scn vector 3. I'm going to do cc dot x for the x position, cc.y for the y position, and cc.z for the z position. Now if we run our app, let's try it out in augmented reality world to place a cube at the position of our camera. Alright, so we can see if we add a cube, it will get placed in relation to the position of the camera. So let's add another one here. Sometimes it actually takes a bit. As we can see, it's just been added because augmented reality is still quite processor intensive. So if you do add a lot of objects, it will go slow. And if you're running a lot of calculations, such as getting the camera's position to place it there, it can run a bit slow. So since this is a newer technology, keep that in mind when creating AR apps. So let's take a look at how we can place an actual object in AR. Alright, now we have placed a cube. Let's place an actual object here. So I've got this folder of 3D objects, so we're going to drag that into Xcode and copy the items. You can download these in the description below, and these objects are taken from the Apple Augmented Reality Kit example. So we have a candle, chair, cup, lamp, and vase. We're going to place a cup in our augmented reality world. So let's fill out the add cup function to add a cup to the camera's position. Let's do let cup node equals scn node. We'll copy this camera code, and instead of placing the cube node, we'll change that to cup node position. So this is placing the cup node at the position of the camera. Do guard let virtual object scene equals scn scene, and this is going to be named cup.scn, and then do comma in directory colon models.scn assets, which is that folder that you just dragged in, /cup. Finally, we're going to do an else and return. So what this is doing, this tries to load up our 3D cup, and if it can't find the file, it will simply return and not run the function. So finally, to place the cup in augmented reality, we'll do let wrapper node equals scn node, and then we do in this for child in virtual object scene dot roots node dot child nodes. Do child dot geometry question mark dot first material question mark dot lighting model, and we're going to make that to be physically based. Then we'll do child and finally do wrapper node dot add child node, and in this we'll do child. Next up is cup node dot add child node, and in here we'll do wrapper node and do scene view dot scene dot root node dot add child node and add the cup node. Now I'm going to explain what nodes are after I show the demo of this working. So if you're not too sure what this is doing, don't be too worried. Essentially, a virtual object can contain many nodes, so it could contain, for example, our cup has a plate for the cup, the actual cup and spoon. So that could be 3 nodes. So essentially, that's adding all of those into this one wrapper node, then adding it to our scene. So let's run that now and see what placing a 3D object looks like. Alright, so let's add a cup object to our world. We can see we have the plate, the cup, and the spoon. So this is what I was mentioning earlier in relation as to how one object can have many different nodes. So these objects are from the AR Apple tutorial. So we have other objects such as chairs, candles in the package that you downloaded for this that you can have a play around with and put in augmented reality land. So now we're going to look at what nodes are, how nodes work in relation to AR, and then I'm going to come back to the code so you have a better understanding of the code once we go through this nodes presentation if you're not too sure how they work. And if you haven't already, check out our complete iOS course in the description below. It takes you all the way from creating an app at the start to monetizing your app and deploying it on the App Store. So let's get into the presentation. Alright, so if you're not sure how nodes work in terms of ARKit, or I guess if you use Seemu or anything like that before, let's take a look at it now. When we open up our ARKit app, it places a root node down at our current position, which is on the XYZ plane in 3D coordinates, and this is at position 0, 0, and 0. So if we add a cube node 1, it gets placed as a child of the root node. And let's take a look at our 3D plane here. So this cube node 1 is placed here, which is positive 10 on the X plane. Now we go on to add our second cube, this time at minus 10 in relation to the root node, and it gets placed at minus 10 on our plane. Remembering the root node is at the center here. Next up, we place a cup object, and this is at minus 10 on the Y plane. Now we place a spoon node as a child of our cup object node at position 0, 0, 0. So where do you think this spoon is going to get placed at? Will it get placed at the 0, 0, 0 where the root node is? Or does it get placed at the same position of the cup? If you guess the same position as a cup, you are correct. Child nodes get placed in relation to their parent node, and that's all they know about their position. So you might not think this is so useful, but if you go on to code more in ARKit, you will definitely be using this. For example, here we can place our spoon on top of our cup, as we can see here, and let's look at another example which outlines this into more detail. So let's take a look at our node structure here. We have our root node, then we have our earth node here, and the earth node's child is a moon node, which gets placed to the right hand side of the earth. Now let's pretend we have a model of our solar system in augmented reality. And our solar system is actually animated. We can see moons spinning around, planets flying around, and the sun in the center. So let's just focus on the Earth and our moon. Our moon, as you know, rotates around the Earth. So let's say our moon node has an animation to do that. What do you think happens when we then move our Earth node? Does the moon get lost and stay rotating around this spot? Or does it move if we move our Earth to the right along with it? Our moon will move along with the Earth because all it knows about is its position is in relation to the Earth node. So it's tied to that. So that's why it stays with the Earth when we move the Earth. So this makes it quite easy to code in ARKit objects that stay together and that are placed in relation to one another. So this is essentially how nodes work. And knowing that now, let's take a look at our code to understand it more, now that we have that knowledge. Okay, so now that we know what exactly nodes are, we can actually tell what the code's doing. So by add cube, we get the camera coordinates to the root node. We add the child node, which is a cube node, and the camera coordinates are in relation to the root node, which is kind of the starting point when we open up our app in AR. So that places this cube node in relation to the roots node based off the camera coordinates. So that's how it knows where to place our cube. And finally, in add cup, it does the same thing, and you'll probably understand this for loop a bit better now, because our cup, as you can see, it's got the plate, it's got the cup itself, and it's got this spoon. So an object, 3D object, could be made up of many nodes, so to speak. Say if you had the planet Earth and a moon rotating around it, that could be one object, but the Earth and moon could be separate nodes. So essentially it grabs all our nodes from a 3D object, adds it in this wrapper node, which kind of wraps all these nodes up into one root node above it. And in our cup node, it adds this wrapper node. And finally, in our scene view, we add the cup node, which adds the actual cup in our AR environment. So just remember, you can download the source code for this below.